Okay, so let's take a look at this graph for this question. We've got a high intensity fishing policy. In other words, we're going to do intense fishing in this system. And we've got a low intensity fishing policy, so we're going to do low intensity fishing. This is the weight of fish in tons. This is how much catch we take. And this is the stock of the fish. So we have 20. We have 38, a population of 38 here, 20 of which we leave behind, 18 of which we take. And you can see over here, we start with the same numbers. So we've got 20 over here, but we only take 6 of them in year 1. So that's why it's the low intensity one. Let's take a look at what the question asks us about. First of all, define the term sustainable yield. So this is a simple definition, which you can easily do. Then the next question, calculate the total catch over 4 years in each policy. So the total catch, we'll go back to here, in each year. So in here we're looking at 18, 28, 36, plus 24. So we add all of those together to get how much our catch has been. And then we do the same for the low intensity fishing policy. We add together those numbers, the numbers of the catch. Okay, calculate the percentage difference between the year 4 catch for the high intensity and the year 4 catch for the low intensity. Okay, so we're looking only at year 4 now. So we are comparing 24 to 48. And the question wants to know the percentage difference. Okay. So the difference expressed as a percentage. So the difference is 48 minus 24, so that's 24, and out of it's low compared to high, so we're doing 24 is the difference out of 24 times 100, so we have 100% difference, okay, between the two. In other words, this is double yield from the low intensity in year 4. Predict, giving 2 reasons which policy would probably give the greater profit over 20 years. Obviously, you know, the low intensity, so we want to predict. Now, quite often, I would say in the majority of times, when there's a predict, you could argue on either side. So low intensity give the greater profit because the stock is going to keep increasing. But we could also argue the high intensity, perhaps it could be the case that this fish is very marketable, and so harvesting as much as possible might on average give us more over 20 years. But I wouldn't recommend, it's quite obvious from here that it's going to be the low intensity. Another reason, so we need to give 2 reasons. So one is that we've got higher catches as the years go on, but the other reason being that the stock is constantly increasing here. Outline 2 reasons why hunting and fishing may not be controlled by legislation. So here we've got, it's difficult to, so monitoring is very hard. It's hard to define, like you need to have international agreement. So although one area may be protected, another area may not be. You've got poaching, so you've got illegal activity, so perhaps even linked to poverty. I mean, it's very well to have a law, but if people are so poor that they have to poach or for food in the jungle or to fish, then they're going to do that regardless of the consequences. Compare the energy efficiency of terrestrial and aquatic food production systems. So we talked about low efficiency in aquatic food because when the sun is shining into the water, a lot of that gets reflected or scattered and doesn't reach the phytoplankton in the water, whereas in the terrestrial system, the plants are directly receiving so much more of that sunlight. So we've got lower efficiency in aquatic, but then we've got higher efficiency further up the food chain in aquatic, because there's no need to waste energy on skeletal support, on temperature regulation. The water helps with all of that. One possible solution that a technocentrist might give to the problem of overfishing. So really solving any of the problems we have with overfishing, we could look at fish farming, aquaculture. We could look at monitoring systems, perhaps using satellite, using drones. This is a new big thing that conservation biologists are using to monitor poaching and also to look for endangered species, as they can use drone technology to search and monitor wilderness areas. It might be the case that there's tracking devices on boats and that track back to satellites that allow them to see what's going on in the boats. It might be the use of genetics to monitor fish populations and to help us to learn more about fish populations so that we can calculate those sustainable yields.